Welcome everybody to GW Insights and our continuation of the Legacy Transformation series that we started a couple of weeks back. Today, I think I'm going to introduce you to Mark Simpson, first of all, who's Technical Director at GW. Hello, Mark.
Hi, Reuben.
We're really going to make you graft and work hard today. So today's about earning your cheese because for the last couple of weeks, we've been talking about a whole host of issues around digital transformation, legacy transformation, around Big Bang. Today is really cementing the answers to all of those problems. So I hope you're up for it.
Yeah, definitely. Let's go for it.
Okay, let's go for it. So we're going to start with one of the first problems that we talked about last week, which was the black box application. And just to clarify kind of what that is for everybody, I think a lot of our listeners and watchers will already know. But that's when you come into an organization and it's got an old legacy system. And actually, a lot of people that set that up in the business are no longer there. Nobody's documented what the system is or where anything is. So it's just a black box. Huge issue when you want to innovate. Just talk us through your approach to getting over that black box problem.
Yeah, certainly. And I think what we find when we go into organizations, people will know what a system is doing, what the inputs are to it, what the outputs, but don't know how it's doing it, or maybe even why it's doing that. So people get away with that and they almost treat that as the legacy system, and over time they drive extra business value around it without really changing it. They might do security updates to it or, regulatory change to it, but they will really shy away from doing business change to it. So over the years, the lack of understanding of that increases, and any change for that is seen as riskier and riskier. So that was one of the reasons why we said that you've got to take a serious look at legacy modernization and legacy migration to new systems. But what it drives as well is when you do that, you've got to tackle this problem. You can't just migrate a system that you don't really know how it's doing something and why it's doing it. You've got to understand what's in that box, not just how you're interacting with that box. And what we see a lot of organizations strive to do with legacy modernization is automate taking the code from the old technologies to the new technologies. And that automation ends up kind of working on the entire code base. So you end up taking all of that black box functionality and almost keeping it as black box functionality in the new system without really understanding, is it doing the right things? Is it structured in the best way for the business? So we think this is one of the key success factors. First success factors is opening that box, understanding what's in it, trying to identify which of that logic is crucial to your business, which of that logic was only implemented because it needed to because of the way the system was implemented, what is redundant and no longer needed, and trying, rather than just taking all of that code and rewriting it, understanding, what you really need, what is the gold dust in that system that really reflects your business. We actually see it quite like archaeology. If you're going and doing archaeology to try and find out and learn from the past, you would dig things up and then you would tidy them up and you try and understand, well, what is the lineage of this and why was it, in that place and why did it look like this? So we see that any automation, the first thing it needs to do is it abstracts out from that black box the key business logic, the key rules, the key processes from that, and try and document that in a way that can be moved across to a new architecture, a new technology. In my experience, any full code-based migration, is fraught with issues and ultimately ends up with challenges.
Okay, so ultimately we're saying do the groundwork, see what's under the bonnet, and that's a starting point, right? That's the answer to this problem, yeah?
Yeah, definitely. And don't trust that if you're going to build something on a new technology, you can just take the code base and run it like that on the new technology. This is adding processing power to the problem. It's about realigning and remapping those systems to what your current business needs are. And you can't do that in an automatic migration. You need to do that by understanding what the rules and what the values are from that system.
Right, Mark. Problem 2. We called it the Mudball in our last interview, but what we're really talking about is monolithic architecture. So when we encounter that, and you'll have encountered that hundreds of times in your career, what's the answer?
So you have to just one answer to rule them all. I think you're going to struggle with that, because I think that this is part of the problem. There's a lot of documentation on theory to say almost monoliths were the way things were used to be done. Microservices is the way you should do it now. And unfortunately, it's kind of not as simple as that. And what do we mean by monolith in essence? Well, it means that all of the logic is in one place, is running together, is all dependencies are being brought into the application. And a microservices architecture is striving to break that up so that things that, struggle being dependent on each other aren't dependent on each other. So things that need to scale can scale, things that need to be fully secure and that's the primary goal can be that. Things where one business unit wants to drive some change over here can be separated out from some regulatory requirements over here. So it's not as simple as saying, well, take that application and break it down to all of its smaller parts. I've actually seen one of the things that I see with many, many different clients and even with, kind of staff that have at times joined GW is they start having a discussion about how big should a service be in the microservices architecture. And I would tell you that I've heard so many paths through that discussion, and I'll give you the answer to that always ends up, and it's, with any architecture solution, the answer is normally it depends. Well, with this question, it's as big as it needs to be. That's what they all end up with, right? So they kind of forget that this is an architecture style. It's a way of saying, don't have all of your logic and processes and user interaction and data storage and security policies all built into one software unit. Break it up so that things can change independently, right? Which has always been good practice in my view, the idea of modular programming and then service-oriented architecture. This is just an extension of that. So also don't rely on large, integration platforms, run something that as a service that can run standalone, and it's been enabled a lot more with sort of the great cloud technologies and cloud platforms that are in place that you can break your solutions down more. But it shouldn't mean you should break everything down to the smallest part. There's always a trade-off. You see that I think it was Amazon Prime in the press fairly recently that tried to break down their service into fairly small, microservices, and ended up bringing things back together for performance reasons or for reducing the cost of support. So, but that doesn't mean microservices is bad and monoliths are great. So once you understand it's not just a formula, take this and break it down in this way, the question comes of, right, how do you break down this monolith then? How do you actually look at your application and say, how should it be structured for taking us forward for all the business change that's needed now? And I would say a couple of the success factors there is, remember, this is a kind of a physical architecture, microservices, it's a concept, it's an architecture style. So really understand, first of all, how you would want your future state architecture to be structured to meet the business change that's coming. So first of all, start with your business domains, right? And think about, are we mixing things together? Have we got units of code that are trying to satisfy one business area as well as another business area and driving it together, right? So we always kind of start with trying to get a domain-driven design approach of what does your business really look like? Ideally, your software should map onto your business at the highest level. Each of the parts of the solution, each of the services should have clear purpose, but for each of the areas should have ownership, should have product ownership within that. So that's the first thing, to try and structure it in that way. But then don't just stop there, and don't result then in a really chatty architecture. If there really is two business areas that work closely together, start considering those together and see what they should share and see where they should get shared services. And also, don't just design your services to meet what your customer requirements are and what your business domains are. At the end of the day, the software that you're building needs to run, needs to scale, needs to be secured, that meets all of your more what we call asset ownership and operational readiness elements. So because you want to get a service that will give you, kind of one of your orders and another requirement for something that gives you your whole history of orders across all of your client base, from a business point of view, it might have the same business owner, but those are two very different requirements for the infrastructure and for the running of that solution. So maybe share the definitions of what an order looks like, but implement that as two different services. So we have a series of steps that we go through when we're assessing, does that architecture meet what your business and operational needs are? And it's a staged approach of looking at it from the business, looking at it from all of the kind of the non-functional requirements and the success factors of meeting future growth and scale, and then look at it from a support and operational management point of view. And it's all of these things together that will come up with kind of your ideal sort of future state architecture. And then the one rule is that will change. So you've got to build it to adopt over time as your business changes or as you learn how your consumers are using your system.
Yeah, that makes a lot of sense and fits in again with what we talk about time and time again. Pace of play, innovation, and changing of technology. You're set up for all of those three things, aren't you?
Yeah, definitely. And if you are tied to dependencies that are stopping you from implementing business change, then there's a problem with your architecture. You need to reconsider that, and you need to really think about how to solve that base problem before you can go and really reap the benefits of the solution.
No, that's brilliant, Mark. Thank you for that. So, Mark, we're on to problem 3 and solution 3. You're earning your money so far, which is great. So we're going to talk about integrations and dependencies now, and we kind of touched on it in the last point even. Quite often, it's not just 10, 15, 20. It can be 100 or hundreds of integrations and dependencies. Obviously, that creates a huge amount of complications. What's your view on the best way around this and how we can actually set the best platform up to continue being innovation-led and make sure that pace of play is at least as fast as our competitors?
Yeah, sure. I think this is a big topic for me. We've worked in integration for many, many years. I'll be giving away my age if I said when I wrote my first integration between two systems. But I think that it is really, really important we get this right. Migrating a legacy system to a new technology is only half the story. That system, if it's an enterprise system, needs to ensure that all of the integration touch points to downstream systems that you're dependent on and that you're providing data for need to work seamlessly within the new system. And I'd say it's one of the biggest headaches for the large programs, that they can be quite clear on what they're in control of and what they can transform their application to, but making sure all the dependent systems still work and making sure that everything you're dependent on is still plugged in is probably one of the biggest challenges. And it's a challenge that there's been many solutions over the years. And actually, if I do a bit of history here, when people started looking at enterprise IT systems, the proliferation of integrations just grew, really quickly. I don't even just mean the systems that you're trying to integrate together, your finance system with your ERP system, with your CRM system, with your customer facing portal. It's the touch points within those. Within each of these, there might be 10, 100 different touch points where data's flowing between these systems. So you end up with quite a large problem. And what vendors did to solve that problem is came up with integration platforms, integration tools. You would have middleware as a whole topic of conversation, really, and a whole, kind of SKU unit of tool sets from the vendors. And they were needed. It helped you get all of the disciplines for talking from system 1 to system 2. Gave you mapping tools, gave you error handling, error hospital tools, gave you transaction management and orchestration over it, gave you the monitoring tools, all very good and popular. A lot of large companies, integration companies, were acquired by the large vendors, by IBM, Oracle, SAP, so the likes of MuleSoft, the likes of BEA, who had integration service buses, were all kind of acquired by the large apps vendors to make it easier for you to integrate between two systems. Now, what tended to happen in the market is people not only use those integration platforms for integrating between very well-defined SaaS applications or on-premise enterprise applications, but they used it for their custom systems as well. So people wrote services, web services originally, API kind of implementations of those more latterly, that use those integration platforms features to allow you to talk between your custom systems as well. And what tended to happen in my experience when I went in and reviewed these with clients is business logic bled into those systems. When there was a misalignment between system A and system B, and one treated the business object in one way and another in a slightly different way, that was built into the integration platform, and it became the most critical element, the central nervous systems of people's applications. And not only it became the central nervous system for the integration touch points of making sure everything was monitored and worked smoothly, but for business logic as well, for orchestration of multiple steps to the system, for error handling strategies from the business, that if that order isn't created when we want to create a shipping, what do we do? And became hugely complex. So then grew beyond kind of an integration platform and more part of that solution. And I've seen a lot of sort of failures of solutions, not because of system A and system B, but because the integration was failing between them. Seen a lot of integration platforms that have just stored so much data. There was a term called dehydration that I still probably, wake up with hot sweats from, where the idea of that is any state that is stored within the integration platform is written down to a database, allowing you to wake up again and continue where you were in that integration. So if something needed to do 3 steps and the second step was taking a long time, it would store all the metadata about that request and where it had got to. It would store it to the database so that if anything went down, whether system B went down or the integration went down or the network went down, it could recover and continue. Great in theory, great on practice, but when implementers wrote hundreds of these orchestrations, suddenly that was the bottleneck. Suddenly that database was the one causing the problem, which is crazy because the whole point of this integration was to ease your burden, right? So that's where we've got to, and I still see a lot of integration solutions that have these big integration platforms in place with a lot of logic in, a lot of orchestration, a lot of state management, and it's part of their challenge when they replace it, right? Now, there's a couple of things that we can do to make sure we're successful in that. The first is you've got to treat that part of the legacy. You can't say, oh, that's just the integration. So when I replace system B, I'm just going to look at system B as system A and get them to work. You've got to have skills to be able to analyze that integration platform as well. We can also learn from open source. technologies. So open source has been a huge success over the last sort of 20 years at being able to change rapidly, being able to take in new advances and innovations from the public, from industry, from people who are working across different projects, and be able to update their systems and be able to say, well, there's the code. You take that code when you're ready to take it. You take the version that's appropriate for you at this moment in time. So not tying you to platforms and products, but giving you tool sets to be able to use yourself.
But of course, that's exactly what the vendor doesn't want, right? Because the vendor wants cold, hard cash, right?
Yeah, and indeed, absolutely, and wants to ultimately to tie you to that product. They want business value, but it's great if you can take their big next upgrade and you can be a long-term customer for them.
Yeah.
So the question for me is, how can you take both? How can you take the investment that the vendors have done, but also the view that you don't want to be dependent on those platforms, that you want to be able to take your integrations and move it to other areas? And this is where actually the industry has gone down a good route with kind of API management tools, where they're saying instead of dealing with actually the service implementation and running that on our platform, you can run that service integration, service implementation for any integration or business logic on your chosen, cloud platform, your chosen Kubernetes implementation as an example. But what we'll do is we'll deal with the boundaries between two systems. So when you're calling an API, we'll make sure that's fully monitored. We're handling any errors, in calling that. We're making sure that is secured and you're allowed to call that. But we're not going to deal with any of the logic of how you're going to orchestrate, a number of calls together, or the workflow that you're going to kick off if there is an error that can't be handled automatically. So these integration layers have definitely thinned out to more policy-based integrations where you can apply policies across it. And this means that, this kind of the mapping of the APIs from one system to another, will have some business logic in. How do you want to use that dependent system? And it's more now like the patterns of dragging in an open source library to create a PDF, let's say from JavaScript, where you're saying, how do I want to use that API that I'm dependent on? What do I want to put as the input? What's my success criteria and my acceptance criteria for calling that? And you can treat that now as, rather than just an external dependency that you're trying to integrate to, as a first-class citizen almost in your product, although it's been implemented by someone else. Yeah. And you can start saying, right, what do I need out of that? What will the test look like? We do quite a bit. We've been looking into contract-based testing, for instance, which is sort of trying to share with your partners how you're going to use their dependent API and creating with them a test that can be run so they're not breaking your code. So really treating these dependencies as first-class citizens in the new system. And I think that's one of the key success factors of suddenly not being dependent on a large integration platform, taking that into your own ownership of that.
Not all integrations are the same, right? So some we're dependent on and others we're pushing out. Talk us through how it's not just one size fits all.
Yeah, it's a really good point actually, Reuben. In this, there will be certain systems you're dependent on, and they'll be written in different technologies. And this is where integration platforms really help. They help to create adapters that would allow those to, be treated the same. And you still want that same approach for the dependent systems. You want to write something that exposes the functionality in that in a way that you can easily consume via API, so that still fits. But even more important, you need to make sure your system, as you change it, is still giving what other systems who are using your functionality need, right? There's a great sort of law called Postel's law that's been used in a lot of design patterns. I know, for instance, Martin Fowler referenced it in over 10 years ago in his integration design patterns book. about being conservative in what you do, but be liberal in what you accept from others. So be very careful on the APIs and the dependent services you use. Make sure that you are monitoring it, expecting errors in that, dealing with failures in those. But for when you're accepting requests from others, be tolerant of what they're doing. Make sure you've got backward compatibility. Make sure that when you roll out a new version, you can allow those consumers to move at their own pace. So when you're designing a new system and migrating your legacy or transforming your legacy from it, you really need to put the effort into thinking about how those APIs will work that allow your consumers, to accept it, to use those systems in the way that they want to use them. So, really a legacy system cannot be transformed until everyone who is using it or integrating to it gets what they need out of that integration. And we have a lot of discussions and put a lot of effort into design of how things should be, where things should be backwardly compatible, where actually it doesn't make sense, and we want the consumers to move to new versions, and how normally where we do a middle ground of a staging between those. So really important to think in that way, I think.
So Mark, we're moving on to what last week we called our first class citizen. And I think we would always consider on any job, we've got a data first approach. So it's that big one, it's data. Talk us through the complications and how key stakeholders are always absolutely frightened to death about losing key data and key findings. Talk us through the answers that we've got for that.
Yeah, I think this is a massive and really important topic, data is. And of course, as you transform a legacy system, one of the things that undoubtedly will come across is the data. You can't start afresh, with the data. You've been running your business for many, many years on this system, and there's really important information in that data. A lot of large transformation projects that fail are the ones that just treat data purely as storage. We've just got, storage of what was needed for that application to run. Just move that storage across, do some data migration, have it as a separate stream, and everything will be okay. We think of data up front. We think of it absolutely as one of the key criteria for success here. We don't just think of data as what is stored in the database. It's the metadata. It's what's in the logs, what's in the analytics, what's in the monitoring of the user's behavior. How people are using the system. That there's data around that as well. And ultimately, the data that is stored is the essence of the business. That's where people's orders are. That's where the decisions are made. That's where your customer base is. That's the essence of your business. Let's really treat it like that. So whenever we do data transformation, the first and probably the single most important question we ask is the database schema fit for your future business, right? So does it reflect what the business needs to achieve? And really, if you took a logical view of your database, so I don't mean the naming of the tables, but if you took a step back and did a logical view data model of your data, your business people should understand that as your company. That is what runs our company. That is what makes up our company there. We have orders, and we have customers, and we have campaigns and then initiatives. If they can't recognize their business in that data, in that logical data model, you've got a problem straight away, right? So that's one of the first things we do is we review that, we extract out a logical data model of that, and we question, does this meet what your business does now? If there's things quoted in that you did 20 years ago but no longer did, then that's important to know, right? And that helps us come to the question of, should we keep the essence of this database scheme? We might split it up into domains, and we might do some refactoring, but do we keep it? And we might move it to new technologies, but do we keep the essence of it? or does it need some redesign to better align with the business, right? And as the business goes through this change, we don't want to just look when we're saying what is the logical representation of what the business does. We don't want to just look at that database tables. One of the big things we look at when we look at data is actually the screens, how the users or your customers interact with you. That's how they see your data from the outside in, right? So we go through a fairly, kind of well-trodden path that we've been doing for many years of looking, first of all, at that user's interaction with the system, recording the screen interactions and recording the paths through that screen. We have a technique that we've used for many years called RDA, Relational Data Analysis, that allows us to go through, trace the screen usage, and generate out a data model that would support that. We've actually more recently used some AI modeling tools or some extraction tools to record those images and to use a large language model to say what is the best representation of that screen interactions in data. We took it another stage to generate our first step of the API definitions to support that. So that's all work in progress that we'll share more about in the future. But the principle is still the same, that first understand how your customers and how your business users view the data in your business. Then go and get the logical model from the database. Then go and look at what the future strategy of the business is. Is there anything that in the current system they can't support or they want to move to? So that allows us then to generate out a new 2B data model of the system. What we can then do with that 2B model is trace it back now to the as is to say, is this fit for purpose as it is? Is it fit for purpose with a series of refactoring and changes? Or should we start again and use a new, better model to map where the business wants to go? And then that gives us our data migration strategies around that of what we need to do and our coexistence strategies and etc. It affects everything in the program. And, this is one thing we're fairly adamant about. Think about data first. Do not separate out a data migration stream that at the end of the design, it's their jobs to try and bring the old data into the new system.
No, that's brilliant, Mark. I think that business first approach, coupled with our views on data that are pretty immovable and are the foundations of what we do, I think as a stakeholder, that would give me tremendous confidence of the approach.
Yeah, indeed. And it's there's another point. You triggered me by talking about stakeholders. Different stakeholders have different views of the data. If you talk to the operations director, they'll be very interested about every single, detailed bit of data. So the commercial manager or the marketing manager, they want to know the customer's view of that data. And what has tended to happen with a lot of legacy systems is all those viewpoints of data have been collated together for one general data model that fits all. So you end up mixing business logic, regulations, compliance elements, IT support elements. So the important thing when you're refactoring that data model is thinking about what is the core essence of the business model here in the data. What is there for customer experience, for workflows, for managing elements, what's there for what's layered on for auditing and stuff, and don't treat it all the same, look at that and thinking what's the best way to model for each of these different perspectives.
Well, we're on to our next problem and our next solution, and it's never been more apt, really. And it's about the volatility of technology. So I think we've seen how fast things have moved on in relation to kind of AI and the battlefield that's been sent between that's out there now between the big vendors playing out. How do we back the right horse? I think is probably the right question.
Yeah, it's a difficult question, and what I've seen with a lot of companies who have not made the move from their legacy systems is because they do endless POCs on new technology. They will look into, 20 years ago, how they can move to the web and Java, and then think about, well, which framework should I use on that? And we've seen a similar kind of set of questions around moving to more browser-based coding in JavaScript, where people would say, well, do I use Angular? What's coming next? Should I use React? There's these new technologies, new libraries coming out with Vue and with, there's something that Solid does great. So you get a lot of technical staff trying to say, I'm not sure we have the right roadmap of where to go next. I want to look at the next, new great thing. And they never start that race almost, let alone, which horse to back. They never kind of start on that. And there's always going to be change in technology. It's always going to improve. It's always going to go around cycles where everything happens on the client and then everything moves back to run on the server for performance, and management reasons, etc. So if you're thinking about, well, let's choose a technology or a set of libraries or code that's going to last me for 10 years, you're looking at the wrong problem straight away, right? You need to think about the generational shifts in technology, the move towards end-tier technologies, the advent of the web, how AI will impact us more recently, how we can scale to more cloud-native apps. So those kind of things you've got to consider building technology that can move towards that. But if you're getting hung up on making sure you spend 12 months deciding on which JavaScript toolkit or framework or libraries you're going to use, then the problem is solved a step before that. It's about thinking how you design and build your architecture that can leverage out all the advances in the UI technologies, that can leverage all of the advances in cloud platform technologies like serverless and like Kubernetes, event-driven architectures, and how you can leverage all of the data storage and processing, kind of tools, like more NoSQL and more things like Databricks for high data processing. So if you start thinking about your architecture in those ways, and then building for change, building for saying, today we're going to use this JavaScript library, React maybe, but we want to have an approach where it's appropriate to use something like Next.js or to build some visualizations in Svelte, for instance, that we've got a goal for our developers to say, we're using that today, but I want an architecture where I can continue to innovate. So, you should not be rabbit in headlights of saying, where do I go next? What will be the impact of AI on our development? Which of these libraries integrates best to Copilot, etc.? Think about getting your architecture right. Think about making advances with certain, technology shifts, and then building to allow and empower your engineering teams who've got the mastery in these technologies to use the right tools for the job at the right time.
Okay, Mark, we're on our last one, and I think it's something that we see time and time again, and it's a huge frustration, not just to us, but also to the client and the people that we want to collaborate with. We call it the business change freeze. So talk to us about how that tends to play out, why it does, and then what our recommendations would be.
Yeah, and I think this one is the culmination of a number of the challenges that we've talked about already. This is where people end up. This is the end game. In that, if you've got a large transformation program where new functionality is being built over months or maybe years, right? One of the first questions, well, maybe not the first question, but one of the critical milestone questions that comes up is saying, do we go big bang or do we go for a staged delivery? Right, and everyone wants to avoid big bang because of the risk that's associated with it. If any of the integration partners are saying, well, it's the only option to go big bang, then I would really scrutinize and questioning their reasoning around that. So what becomes abundantly obvious through any transformation problem is that there's going to be some need for coexistence of old and new. you're going to need to gradually stage the rollout of the new functionality, right? So it becomes really, really important then to come up with a strategy for how that should work. I've seen a lot of transformation projects dictate to the business that we're going to need to freeze business logic. We can't, satisfy new initiatives while we're changing this system. So, how long is it appropriate to change, to freeze what you're delivering to the business? Well, in sort of the digital age, if you're not changing and improving, your competitors will, and your customers will go elsewhere. So it is absolutely important that this, again, is considered as one of the key success factors of any transformation program. The ability to not freeze the business initiatives, to be able to change things as you're implementing the new technologies, to be able to roll out functionality gradually so that you don't have a big bang. And I think that, this is one of the answers that you need early on in the program. How are you going to do this? And we've worked on many kind of legacy transformation programs, and it's not one size fits all. There are some great patterns, there are some great techniques to do this, but ultimately some design and thought needs to go into your specific problems and products.
Yeah.
You've got to identify what the biggest risks are early on, and you've got to have an architecture that allows the old and new to coexist. So I see some programs where they set a separate stream for coexistence, but it's decoupled. So the team who are building the new system, don't worry about the coexistence. That's another team. And then what that becomes is an integration problem then. That's one of the integration systems, whereas actually that shouldn't be the way it is. So for instance, we did a solution where we evolved the UI of one of our customer-facing systems that we wrote, and it was written probably just 6 years ago, the UI, on a technology called Oracle Jet, one of the early JavaScript toolkits that was all-encompassing. It would deal with, integrating to the database. It would have visualization libraries and allow you to do everything in one place, a bit similar to the likes of what Angular would do. And as we were evolving and we wanted more visualizations and a better user experience, it was identified that we were reaching the boundaries of what we could do as a team within that technology. So we wanted to move across to the latest JavaScript front-end technologies, React and Next.js. So the first thing we did, rather than saying, well, we're going to do this set of screens and you're going to have the old set of screens working with the new set of screens, and there might be a clunky user experience, we did a little mini project, a little POC, a Spike, to say, how do we deal with coexistence first of all? How can we get a common look and feel that can evolve to the new innovations that we want? How do we share states between these systems? How do we share all the logging and auditing? So we did a POC that proved that these could coexist, but also proved that every single developer on the team would know how to use the old and the new. Even if they weren't trained in Jet, they could interface to Jet as if it was a React component. So they had the ability to change the old system, change the new system, and we could evolve it, over time. Yeah. We also introduced at that point feature flagging to our solutions so that the solution could be switched from old to new, so that we had more confidence of incrementally rolling that out and rolling it out when it was ready. So things would be in production with the new React screens, fully tested against the production infrastructure, but would only get switched on once the whole set of screens, the journey was consistent for that. So, this is a good example where treating coexistence as a really important factor up front, and designing for it and coming up with a solution and proving things can coexist properly rather than having it as a separate stream, is absolutely essential for any legacy transformation.
Yeah, I think the whole de-risking element, again, wearing the stakeholder hat, just is so sensical, right? And we see time and time again, I won't call anybody out, but if you look at the local authority scene, you know, how often do we see local authorities going bankrupt because of a big program that's just cost 100 million, you know, and it's because they've not gone through the staging, right?
Yeah. Yeah, and what one software architecture component that we always consider and we always question, is there anything more can we do on that? It's something I call scaffolding within the application. So if you've got a legacy system or you know, a legacy database or a legacy set of services or UI, and you want to introduce some new technologies to that, you want to upgrade it, there may often be coding that you want to do on that legacy system to build an integration layer or to make it fit better with the new technologies. And you shouldn't shy away from opening up that legacy system and writing an adapter or writing something that allows you to have the state in a certain format that allows you to use that in the new system. You know, and it's like putting on scaffolding in a building to make sure that doesn't break while you're building your extension or whatever. So I think that's really important. It's really undervalued, and that is what allows then you to have joint teams of developers who know the old technology with the new technology working together. That's their integration layer, their common language. And again, any legacy transformation project that only has skills in the team in the new technology and is treating the old technology as a black box, you know, that's a recipe for failure, really. You want a joint team, people who can look at the old technology, look at the new technology. We've written a few tools to help bridge that gap, you know, to help come up with integration layers, to help. We've written a tool that helps our JavaScript and TypeScript developers to interrogate and understand PL SQL logic in the database so that they can identify areas where business logic is implemented at the wrong layer and generate our TypeScript and JavaScript code to implement that correctly, and to keep the interaction with the database at a SQL level rather than, you know, kind of tying a lot of the business logic to it. So there's a few tools in most companies' arsenal to be able to deal with that. But the most important factor is, you know, assume that you cannot freeze that business. You cannot go big bang, and work that into the plan how you're going to prove that coexistence.
No, that's brilliant. And I think we're all out of rope there, you know, but I think we have given some very realistic and structured answers to what those problems have been in the last couple of weeks in those conversations. So my head hurts a little bit, but thanks for your time, Mark. And I think for anybody watching or listening who's going through those issues right now or trying to work them out or has gone through them in the past, you know, we've said there's not just one way to skin a cat. So it'd be great to hear about your approaches or your current issues. You'll find Mark Simpson on LinkedIn. You'll find myself, Reuben Boughton, on LinkedIn. So feel free to reach out and engage, even in the comments here. We'd love to hear from you. Thanks for your time again, Mark, and I look forward to chatting again in a couple of weeks.
Yeah, thanks, Reuben.